Alright, equal to 3 to the power of x, and y is equal to log of x to the base 3. Take a look at the first one. If x is equal to 0, y would be equal to 3 to the power of 0, which is equal to 1. So our graph going to pass this through this point here. If x is equal to 1, y would be equal to 3 to the power of 1, which is equal to 3. So x is equal to 1, y is equal to 3. So my graph is going to pass this through this point. If x is equal to minus 1, y would be equal to 3 to the power of minus 1, which would be 1 over 3. So somewhere around here, as you see, your graph is going to get closer and closer to 0 from the left side, and passes through point 1, and then exponentially increase. That would be a graph of y is equal to 3 to the power of x. To graph y is equal to log of x, let's take a look at some of the properties. If I have log of x equal to y, we need to know how to convert that into exponential. Anybody know how to do that? Those of you who are watching this lecture, remember how to convert log of x equal to y into exponential. You take the base of the logarithm here and you raise it to the power of y and you let it equal to x. You need to know this relationship for most problems that we work in this section involving logarithm. So you need to know how to convert from logarithm to exponential. So the base of the logarithm right here to the power of y would be equal to x. So in this case, we want to figure out what is a log of b to the power of a when the base is also the same as b. So if the base of the logarithm it turns out to be the same as this number here, we want to know what this number would be. If I convert this to the exponential, that should be pretty simple. Let's take a look. In this case, so b to the power of what I'm looking for here, I'm going to use this little box, is equal to, my x would be all these terms here. That's my x, which is equal to b to the power of a. So just by looking at this, what would be that little black box should be equal to then? Pretty obvious now, right? Must be equal to just a. So in other words, if the base of the logarithm, I'm going to show you a few more examples here. If I have a log of 3 to the power of minus 1, if the base happens to be the same, can somebody tell me what this is equal to then? So the base of the logarithm is the same as this. So the whole thing should be equal to this number here, whatever that number is. So it would be minus 1. So let's take a look at another example. If I have log of 3 to the power of 0, if the base is also 3, what does that is equal to anyone? What's that? y1. This is 0, right? So it would be equal to 0, right? So again, if the base of the logarithm it turns out to be the same as this number here, this whole thing would be equal to whatever number that is here, right here. Let's take a look at another one. If I have log of 3 to the power of 3 to the power of 2, what is that equal to? Just 2. Very good. So that would help me to figure out these numbers here. So if I have, if x is equal to 3, If x equal to 3, what is y then? Y would be log of 3 with the base 3. What is that equal to, anyone? That would be 1, because the exponent here is 1. So if x is equal to 3, y must be equal to 1. So my graph going to passes through this point right there. Okay. So let's take a look at another number. If x is equal to, let's say, what number can we pick here? Anyone? If x equal to, let's say, 3 to the power of minus 1, or 1/3, right? So y would be equal to, what is y? Negative 1. Okay. So this is 1/3, right? So if x is equal to 1/3, 1/3 would be, this would be 1/2. This is 1. This is 1. This is 1/2. 1/3 would be somewhere around here. Y would be equal to minus 1. This is minus 1. So that would be somewhere around here, right? What other number can I pick here? I want to know, where does this intersect x-axis? If I let x equal to how about 0? If x equal to 0, would that be a good number to pick? You want to know when, well, let's pick 1. If x equal to 1, that's probably the better one to pick. If x is equal to 1, so we want to go log of 3. Okay, so we want to have 3 to the power of 0. Does that work? So here is, what is 3 to the power of 0 is equal to? No, 3 to the power of 0 is not equal to 0. Anything to the power of 0 is equal to 1, right? Great. So 3 to the power of 0 is equal to 1. So you want to know if x is equal to 1, then we have log of 1. I'm going to replace 1 with 3 to the power of 0 so I can see that it's equal to 0. Everybody see what we're doing here? So if x is equal to 0, y is equal to, if x is equal to 1, y is equal to 0. So my graph going to pass through this point here. So the graph looks like this. You get closer and closer to 0 from this side, and it would get look like that. So I pick these numbers: x equal to 3, x equal to 1/3, and x equal to 1. And then I replace 1 with 3 to the power of 0, so I can use this property. So let me write this property one more time here. If I have a log of a to the power of n, if the base of the logarithm is the same as base of this exponential, which is, this is also a, so what is this whole thing would be equal to, anyone? N. Excuse me. That would be n, exactly. So this is a very handy equation to remember, and that's what we're going to use to locate these points.